Okay, this is 7th grade lesson 6.4. The objective today, students will develop an intuitive understanding about how to find the surface area of a pyramid. The standard covered in this lesson is 7G6. The page numbers out of the hardcover book are pages 270 through 275, and out of the practice journal, page 149 through 152. Today we're going to be working with surface area of pyramids. So just to break down and kind of review things that we've previously learned. We did in our previous section learn how to find the surface area of prisms. And a prism is when you have two bases. So how is a prism different from a pyramid? Well, a pyramid only has one base, and then it comes to a point up at the top, okay? So a regular pyramid, just for some vocabulary, a regular pyramid is a pyramid who has a regular polygon base. So what does regular mean? Well, the word regular in math means all sides are the same length, all angles are equal. So for example, this base right here that is a square is regular because it has a dimension that is the same on each side. Like if these were each 4 centimeters, well, all sides have 4 centimeters. So they're talking about the base having a regular or being a regular polygon. The lateral faces are triangles. So lateral, what does that mean? That's the part that kind of consumes what I would call kind of like the middle. It's the part that comes to the point. So all of these faces are what you would call your lateral faces or your lateral part of your figure. Okay, when it's broken down into its net, these are our lateral surface area. They come to that point or make up that middle section of the pyramid. Okay, the height of each triangle is the slant height of the pyramid. That's important to understand because as we move into chapter 7, you'll be working with volume. And when you do volume of pyramids, you use a different dimension. So our slant height is just that height of the pyramid, or not the pyramid, the height of the triangle. Okay, that's what our slant height is. And they will indicate that one way or another. Usually you're going to see, as you advance further, you're usually is going to have your pyramids look in this format versus the net format that I have off to the right here. So the formula that we're going to use, or the breakdown of what we're going to use for finding the surface area of a pyramid, is we're going to find the area of each of those bases, or each of those pieces. So you're going to find the area of your base, and then you're going to figure from the shape of that base how many triangles you have. So it's important to understand that if you have, for example, 4 sides on your base, that means you're going to have 4 triangles, okay? Your base outside, the perimeter of your base is indicating how many triangles you're going to have coming up to create that pyramid. Okay, then you're going to go ahead and add all of your areas of your lateral faces. So on this one, because it's a square, each of those triangles is going to have the exact same area, okay? So we're going to go ahead and just practice some of these so that you can understand the breakdown. So on the left, I have a 3-dimensional representation of a pyramid, and on the right I have what is called the net of that 3-dimensional. It's kind of like where I popped the top of it and let the sides fall down. Okay, so if we notice, looking at this this bottom or base, we have a square. Okay, so all sides are the same, so this would be a regular square pyramid. When we go through and we find the area of that red square, well, to find the area of a square, you do base times height, so 5 times 5 would give us 25. Okay, so that's one of my pieces. Now there's 4 sides to that square, which means I have 4 triangles. And I know that you can see that, but you need to understand that when you're looking at a dimension or a figure that's in this format off to the left, you have to understand that you don't really see all of the triangles. You have to visualize those or understand that if I know what the base shape is, that'll tell me how many triangles there are. Okay, so looking at our triangles, we have a base of this triangle. The distance across the bottom is the same as that right there, which is 5. So we have, for each of these triangles, it is 5, and the slant height is the same on each of them, so 5 by 8. Now remember, to find the area of a triangle, it's base times height divided by 2, or half of your base times your height. So if I do my base 5 times my height of 8, that's going to give me 40. And if I divide that by 2, it gives me each triangle equaling 20 inches squared. So each of these is 20 inches squared. Okay, final step is to add all of our things together. So on this one, I'm going to erase this so that you don't think that that's one of my other numbers. So I have 4 20s. So just to make it faster, I'm going to go 4 times 20 because those are all the same. which is going to give me 80. And then I have my base, which was 25. When I add those together, I get 105. Dimensions are in inches, and this is surface area, so it's squared. So 105 inches squared for this pyramid. Okay, the key thing is working with surface area of a pyramid is just understanding what shapes are making up that whole figure. Okay, you guys should know all of the formulas that you're going to need for a pyramid, but you have to understand how to break that pyramid down. Okay, so when I look at this pyramid, I'm noticing this one's kind of complex. I'm noticing that it looks like I have a triangle base. So that means I have a triangle in the middle. So this is my base, and I don't know that I'm not going to draw the exact perfect triangle base, but I know there's a triangle on there. And then I know there's also going to be those triangles that come off the side of each of those. And I know I am not the best artist, and that's okay. But you can at least get an understanding that we have a triangle base, and I'm going to do that in a different color so that you understand what I'm talking about. So here's my base. And then I've got 3 other triangles that are making up the height of that triangle. Okay, so this one's a very complex one, and every once in a while you're going to get one like this. You have to break down each and every part. So when I look at this, and don't worry about my shape that I have off to the right, I'm just going to pull my information. So this 6 that's right here, I'm just going to say is this because it is my 6 here. Now these may not look proportional to what they should, and that's okay. I'm just using it to indicate what I've got. Okay, then I've also got a 6 here. So this is a 6. And then I've got a 6 here. So what am I finding out? I'm finding out that when I look at that figure, it looks like the bottom is a different shaped triangle, but it's really not. It's actually what you would call an equilateral triangle. So really, this is what my base looks like. So really, my base looks like that. Okay, even though it did not look that way here, from getting my information for these 3 pieces that I got from here, here, and here, it's telling me that each of these is 6. So I can now get a better representation of what this looks like. Okay, there's also some dimensions right here, and it looks like they're doing a line right here. And that's showing me the height of that triangle. I know it's not height when you see it, but it's that distance from here to here on that base. And they're telling me that that is 5.2. Okay, and I have to understand that in order to find the area of that triangle, okay? So then coming off of each of these sides, I have triangles. Like I said, ignore how hideously horrible I am at drawing triangles. So now I have a better representation. I kind of sketched one out so that I could see what was there, and then realized that this here is actually a regular or a equilateral triangle. Okay, so now if I go through and I do this, the only other thing that I have not copied down was this 10 that was right here, and that was the height of these triangles, the slant height. So this was 10. Okay, so we've got that red triangle in the middle that is 6 times 5.2. Now remember, it's a triangle base. So we're going to do, for the base, we're going to do 6 times 5.2. And then remember, we have to divide that by 2 because it's a triangle. Okay, you're not always going to divide the base by 2. Like in the last one, we had a square base. We don't divide by 2. But this is a triangle shape, so we have to remember we have to follow that formula. Okay, so 6 times 5.2, and then we're going to divide that by 2. Gives me 15.6. So my base equals 15.6. Now I have 3 lateral surface areas. And I'm just going to put lat for lateral surface area. And the dimensions on those are 6 by 10. So 6 times 10 divided by 2. Now in my head, this is what I'm doing. I took half of 6 and did 3. So then 3 times 10 would give me 30. It's the same as if I went through and did this. 6 times 10 is 60 divided by 2, still gives me 30. Now I've got, those are 30, but there's actually 3 of those. Gives me 90. Now if you need to see those each individually, you could write them out each individually. That's 30. This is 30. This is 30, and then this middle part right here was 15.6. Okay, we're gonna go ahead and add all of these together. You would get the same thing if you added these together that I have written out individually. You have to decide what works for you. So I've got 90 plus 15.6 is gonna give me 105.6. So I have 105.6. The dimensions were feet. And this is surface area, so it's squared. Okay, that one was pretty complex, and understand every once in a while you're gonna have one of those. You're gonna have to break down that bottom figure to decide what all of your dimensions are for your, even for your lateral, because sometimes they'll give you a tricky triangle on the bottom. Oops. Okay, so let's go ahead and try another one. Okay, so this one's tricky. Once again, they're not giving us a square. Now it's not a triangle. It's actually a 1, 2, 3, 4, 5-sided figure. So it looks something like this. And I am terrible at drawing pentagons, but something that looks like that, only it's a regular pentagon. I'm really bad at drawing those. I could probably grab one from up here. Right here's a pentagon. So it looks like that on the bottom. Okay, so we've got that bottom. So this one is set up slightly different because we do not know how to find the area of a pentagon. Could we figure it out? Yes, but we have not learned how to do that. Plus, they're not giving us enough information to be able to find the area of that pentagon. So here's what they're telling us. They are telling us right here that the area of that pentagon that's on the bottom is actually 440.4. So I'm going to go ahead and write that in there. Down here. So this is 440.4. Okay, so now off of each side of that, I have my laterals, which are triangles. And I'm not going to do this on everyone, and you guys probably won't draw them either. It's just for right now when you're first learning it, it's nice to be able to kind of see what the heck I'm talking about as that two-dimensional. So I've got a triangle that has a base of 16, so this right here is 16. And a height that's going up, which I'm going to just draw on this one, that is 20. Okay, so if I do area of a triangle, base times height divided by 2, I'm going to do 16 times 20 divided by 2. Now in my head, I'm going to take half of one of those numbers. So I'm going to take half of 20, which is 10, because I can mentally calculate that really easy. So I'm going to do 16 times 10. It's the same thing. You would get the same answer if you took 16 times 20 and divided it by 2. This is something mentally that I can do a little bit faster. I get 160 for each of those. So how many of these do I have? I have 1, 2, 3, 4, 5 of those. So I'm going to take that times 5. Okay, I've got 5 of those lateral surface areas. And when I do that, I get 800 for the lateral surface area. Okay, my base was 440.4. I'm going to go ahead and add those together. I get 1,240.4. My dimensions were millimeters, so I label it as millimeters, and its surface area, so it's squared. Okay, so that one, once again, was something just a little bit different, having you practice another method. If they give you something other than rectangle, square, triangle, base, they are going to tell you what the area is. So just remember, if you get those, they've already done the hard work of part of it. You're just having to find your triangles. And if it is a regular polygon, all of the triangles are going to be exactly the same. Okay. So here's another one. So I'm going to go ahead and have you guys work off of this one. I'm going to have you pause your video. I want you to go ahead and try working through this one, and then we'll maybe do another one or two of them. So go ahead, pause your video, and work your way through this one. Okay, so on this one, you should have ended up with a surface area of 253.5 meters squared. So I tried to kind of break down so that if you were somebody that was kind of watching as I went, you could see where I was getting all of my numbers. Okay, so let's go ahead and look at another one. Hopefully we'll have another one where it's got the area of the base, just so you can practice one of those. Okay, so here's a word problem, I guess. We've got a word problem. So it says, what is the surface area of a square pyramid? So when they name it as a square pyramid, that means the base is a square. So it's a square pyramid with a base, a side length of 9 centimeters. So each of these is 9 centimeters. Okay, I'm drawing as I go. It just makes it easier for me. And a slant height of 7 centimeters. So slant height, remember that's the height of your triangles. So if I were to draw triangles off of each of these, this dimension that's going straight up here is 7 centimeters. Okay, so how many sides do we have on a square? We have 4 sides, which means we have 4 lateral surface areas. So we've got 4, not lateral surface areas, but 4 faces of that lateral surface area. So we're going to take 4, and then once we figure one of our triangles, we're going to take that times 4. So for my base, well, it's 9 by 9. Okay, remember this is a square, so I do not have to divide by 2 because it's a square base. So 9 times 9 is going to give me 81. Okay, for my triangle, well, my triangle, I have one dimension that's 9 and then by 7. So we're going to go 9 times 7. And it's a triangle, so we have to divide by 2. And that gives me 31.5. And I have to take that times 4 because there are 4 of those triangles there. So if I take 31.5 times 4, it's going to give me 126 for the lateral surface area. And my base was 81. So we'll go ahead and add those together. I get 207. My dimensions were centimeters. And it's surface area, so it's squared. Okay, so that's working a word problem. So when you get a word problem, you need to write down as you go, maybe drawing a picture so that you're seeing the way that you have learned how to solve it with the picture. Okay, so this one's a little tricky, little higher end thinking. So it says a roof is shaped like a square pyramid. So square pyramid means we have a square as our base. One bundle of shingles covers 25 square feet. How many bundles should you buy to cover the roof? So the first thing is, in order to cover it, that would be surface area. So my question to you is, if I was thinking of this as a pyramid, okay, they've told me that it's a square pyramid, right? And looking at the dimensions, that would be 18 by 18. So here's where this is extending on your learning. My question is, if I needed to just get the shingles, would I need shingles to cover the base or this part that's down underneath of the roof? Would I need shingles for the bottom of the house? That would be a no. So when I'm doing this, now I'm logically thinking about what are they asking? They are asking for how much surface area is just making up these 4 sides that are triangles that look like that. Okay, there are 4 of them because it's a square and they're all the same. We don't need the surface area of the base though. Okay, so we're just going to be doing our lateral surface area on this. Okay, so if I go through and I find the area of one of those triangles, so that blue triangle that I see, we're going to do 15 times 18 and divide it by 2. Or some of you might say, I'm going to just do 15 times 9. That's up to you. So 15 times 18, we're going to divide that by 2. And when I do that, I get 135. So I get 135 for one of those triangles. There are 1, 2, 3, 4 sides. So we're going to go times 4. Okay, so I have a surface area that's 540 feet squared. Okay, so that's not answering the question yet. The question asks or states, one bundle of shingles covers 25 square feet. How many bundles are we going to need? So each bundle will cover 25 square feet. We need to find out how many times that 25 is going to go in here. So we're going to end up dividing this by 25. Now, by no means do you have to do that longhand. You can divide that out on your calculator. So when I divide it out, 540 divided by 25, when I do that, it gives me this number, 21.6. Okay, so we have to think once again, what are they asking us? It says, how many bundles should you buy to cover the roof? Can I buy 21.6 bundles? No. So that means in this case, we're going to have to round up because I can't go down to the lumber yard here in Emmitsburg and just buy a 0.6 of a bundle. I'm going to have to buy that whole next bundle. So therefore here, we're going to have to buy 22 bundles. Okay, so that one's extending on your learning, and you have to just understand sometimes that that's a real world situation. That's where you might use something like this. And understanding that when you do something with a pyramid here, that's a very common way that a house, the tip of a house or a garage might actually be built. You have to understand that you're not going to need the base of that pyramid. You're just going to need the lateral surface area. Okay, that's pretty much it for this lesson. So the key thing to understand about surface area of a pyramid, you have a base, and that base is going to tell you how many lateral or how many sides are on your lateral surface. Okay, regular pyramids have the same dimension all the way around the polygon that's on the bottom. So today we worked with squares and triangles. We also worked with a pentagon. If they give you something other than a square or triangle, they're going to tell you what that area is of that base. Okay, and then remember, when you're working with your triangle sides, you must do base times height divided by 2 and count your number of triangles. Add your pieces together, your base and your lateral surface area. That's going to give you your full surface area of your pyramid. Good luck with this.